Today we're going to talk about combinations or operations on functions, combinations of functions. Combinations mean that we can add, subtract, multiply, and divide functions, and there's a notation for this. So like f plus g of x, what that means is really you're adding f of x plus g of x. F minus g of x means f of x minus g of x. F g of x, sometimes you see a dot, sometimes not, means f of x times g of x. And that's not to be confused with another operation we're going to look at called a composition. This is just a multiplication of the two functions. And f divided by g of x means f of x divided by g of x, providing g of x is not equal to 0, because you can't divide by 0. However, we also want to know the domain of the resulting function. The resulting domains of these functions is the intersection of the individual domains, and we'll see what that means. So let's take a couple examples. So here's an example. F of x is x squared, and g of x is the square root of x minus 1. And the question is, find f plus g of x and its resulting domain. What's the domain of this function going to be? Okay, so before we get started, we actually should look at the domain of these functions. So the domain of the original functions, and I'm going to list them here. The domain of x squared is all real, so we would write that negative infinity to infinity. That's the domain of f of x equals x squared. And the domain of the square root of x minus 1, well, you can't square root negative numbers, so my domain goes from 1 to infinity. So these are my domains of my individual functions. So this is asking us here to add these two functions, f plus g of x. So that means f of x plus g of x. And so all we have to do is add the two functions. So if we add the two, we get x squared plus the square root of x minus 1. That is my f plus g of x. So the question is now, what is its domain? So remember, we said the domain is the intersection of these two domains. If I were to draw this on a number line, it would look like this. So the top function, its domain is negative infinity to infinity. The bottom one is 1 to infinity. The intersection is, what does it have in common? What do these two functions have in common? What do the domains have in common? Well, from 1 to infinity is both down here and up here. So the intersection means from 1 to infinity for these two functions. So the domain of the resulting addition of the two functions is 1 to infinity. Let's take another example. So suppose we're given these two functions, y equals x squared, or f of x equals x squared, f of x is 1 over x, g of x is 1 over x, and we want to find f g of x and its domain. I've listed the domain of the x squared is all reals, negative infinity to infinity. What is the domain of 1 over x? Well, we know you can't divide by 0, so that's the domain of 1 over x. In interval notation, we write that like negative infinity to 0, union with 0 to infinity, and it's not including 0, so 0 is not in the domain. That's what we're saying with this notation. So f g of x, that means f of x times g of x, and that's equal to x squared times 1 over x, which can be simplified to x squared over x, which just equals x. So f g of x is just x, and we want to know what is its domain. Well, its domain is going to be the intersection of these two domains, and they're almost the same, except you can't have 0 in the bottom one. So even though when we look at this after simplifying, it looks like all reals, in reality, because this is coming from an operation on these two functions, we have to go back to the original domains and see the intersection. So it says here that we can't have 0, so the resulting domain is going to still have that in it. So the resulting domain is all real numbers except 0. From negative infinity to 0, union with 0 to infinity, not including 0. Now there is one more kind of operation we can do on functions, and that's called composition. So let's take a look at that.